Very good morning to all students. I am Patil Madam and the director of a Krishna coaching classes. Today I am going to deliver a lecture on differentiation. So what do you mean by the differentiation? That is also called as a derivative, isn't it? And the derivative, that is the definition of a derivative, we can take by the counter example. You can derive the definition of a derivative by taking one counter example. So I take one example. Let us consider, let y is equal to f of x is equal to x square plus 2x plus 1. This is the function I have taken. Y is equal to f of x is equal to x square plus 2x plus 1. Now with the procedure, I am taking one procedure, and with the help of that procedure you can come at a conclusion at the definition of the derivative, isn't it? Now let us consider limit del y with a small change in y corresponding a small change del x in x. So the equation 1 becomes y plus del y. This x becomes x plus del x. Here in the case of a x square, you can write x plus del x whole square. 2 remain as it is. X plus del x plus 1. This is second step. Now what you have to do? We have to subtracting 1 from second. So y plus del y minus y f of x plus del x minus f of x, here again x plus del x whole square plus 2 x plus del x plus 1 minus x square plus 2x plus 1. Now again y get cancelled. What is remain? Del y. Here f of x plus del x minus f of x. Now simplify this bracket. X square plus 2x into del x plus del x square. Here 2x, 2 del x plus 1 minus x square minus 2x plus 1. Now again if you observe this, x square get cancelled. Again 2x get cancelled. 1 get cancelled. What is remain? Del y is equal to f of x plus del x minus f of x is equal to 2x del x square plus 2 del x. Now see what you have to do. Divide throughout by del x as del x not equal to 0. Therefore this statement becomes del y divided by del x. Here f of x plus del x minus f of x divided by del x is equal to 2x del x divided by del x. Again del x square divided by del x. 2 del x divided by del x. Here del y divided by del x is equal to f of x plus del x minus f of x divided by del x. Here del x get cancelled, 2x. 1 del x get cancelled, del x. And here again plus 2. Now see, you have to take the limiting position, that is limit. Del x tends to 0. Del y divided by del x is equal to limit. Del x tends to 0. F of x plus del x minus f of x divided by del x is equal to limit. Del x tends to 0. You have to take the limit of every function, that is 2x plus del x and plus 2. Now if you substitute the limit as a del x tends to 0, here you have got 2x plus 0 plus 2 and here 2x plus 2. Now the result, that is the 2x plus 2, therefore the derivative of a function x square plus 2x plus 1, it is nothing but what here 2x plus 2. Right? So the actual definition of a derivative you can define as a limit del x tends to 0, del y divided by del x is equal to limit del x tends to 0 f of x plus del x minus f of x divided by del x. It is equal to 2x plus 2. Now, the ratio, I am going to define the definition of a derivative. Now see, del y it is nothing but the change in the value of y. Del x it is nothing but the change in the value of x. Their ratio and their limiting position, it is called as a derivative. So, how will you define the derivative? The small change in the value, the ratio of the small change in the value of y corresponding a small change in the value of del x, in the value of x, and their limiting position, it is called as a derivative. So, for our convenient, limit del x tends to 0, del y divided by del x, you can write as a dy by dx. The meaning is that ddx of y means the derivative of a y with respect to x. This you can write as a ddx of y means f of x. Again, this notation you can write as a f dash x, and the f dash x you can write as a limit del x tends to 0, f of x plus del x minus f of x divided by del x. And this is the first principle of a derivative. Now, in place of del x, you can substitute approximately equal to h, that is limit h tends to 0, f of x plus h minus f of x divided by h. It is the first principle of a derivative. And with the first principle of a derivative, we can derive the formulas of the derivative. So many formulas of the derivative you can derive with the help of a first principle.